Hello guys, welcome back to this channel. Today we're gonna talk about what are bosons. B-O-S-O-N-S, bosons. What are bosons? I don't know, I have to write the spelling of the name boson. Boson is a question mark. What are boson? These are all particles we're talking about. It's a certain point of energy, right? And in generally speaking, all this journey we're making is about the energy in different states. A certain point of energy means what? Coming down from the atoms, from the molecules to the electrons, neutrons, right, to the quarks, to what is below the quarks is the pions, preons, and the different states of these quarks. It's all about this. So we have today we're going to talk about bosons. What are really bosons? Yeah, something very tiny. We are talking about just a speck. If I take this chalk, if I do like this, see, you can see. Sorry, the chalk has gone down. Sorry. Yeah, this, if I break this, see, let me do this. I don't know whether you see this. You don't see anything. This you can see, right, with your eyes. And I blow it, you can't see it, right? But you can. These things we are talking about are things you can't actually see with your own eyes. You have to use very powerful instruments to be able to see them. So what are they? And from these things that you have made, actually, isn't it funny or strange? Let's go to it. Okay guys, now a boson is a subatomic particle. You know what I'm saying? A subatomic is not atomic. Atom is not an atom, it's below an atom. That's why we use the word subatom. Okay, less than an atom. It's a subatomic particle, such as a photon. You know what's a photon? The light you see from the sunlight or from the stars. Those are photons. Come out of what? Electrons. You can say what's the quanta of electron? It's a photon. If I'm not wrong, of course. I have to check that out. So, such a photon, let's go again, once again. A boson is a subatomic particle, such as a photon, which has zero or integral spin. What's an integral? Area below a curve in maths, right? How do you calculate integral? It's not a differential. Okay, this is something, it's not math, this is physics. And okay, it has an integral spin and follows the statistical description given by somebody called S.N. Bose and Einstein, you know, the famous Einstein. And this camera is not doing me justice, come on. So I don't know whether you can see me properly this way or this way. Now, what are bosons in simple terms? What are they? Now, bosons are particles that carry energy and forces throughout the universe. Let me repeat that again. Bosons are particles that carry energy and forces throughout the universe. Now, the standard model of particle physics, the most robust theory that we all know, we have, which deals with subatomic world, divides these things into two broad categories. So it divides every particle in the universe, and even the larger in the universe, and even the larger composite particles fit into these broad categories, which are called fermions and bosons. So we have been dealing with fermions. Now we're talking about bosons. If you don't know about fermions, or you are coming across this video for the first time, please go back and watch the video we've done about fermions. So we are not going back there, so let's proceed with bosons. Today we're dealing with bosons. Okay, I don't know whether I have to tell you again and again what this is. Maybe somebody who's watching this thing for the first time. And let me see. And I don't know where I just kept that. Of course, I have a lot of stuff here. And the quarks and so on. Now, for those who don't know what a fermion is, or who are watching this video for the first time, let me define to you what a fermion is. A fermion is any particle that has an odd half integer spin. I explained to you what is a half integer spin and one integer spin. And in a half integer spin, it does not come back to the position where it started. It comes to the opposite part of it. It started from the positive part, it stops at the negative part. It's called half integer spin. So it has a half integer spin like 1/2, 3/2, and so forth. So half integer spin, quarks and leptons, as well as most composite particles like protons and neutrons, are fermions. Okay, so that's what I'm talking about here, fermions. Now here in this, what I'm telling you here is that the standard model of particle physics, the most robust theory that we have, which deals with subatomic world, divides every particle in the universe and even the larger composite particles into two broad categories. That's fermions and bosons. Fermions and bosons. That's very important, because when you're talking of fermions, you know these are particles that have integer spin, and when we talk of bosons, these are particles with an integer spin. Okay, so let's go on. A boson is a particle that has a certain, that already you have said, it has spin. Actually, what is this thing called spin? If you go back to my videos, I've told you what spin. It's not necessarily a rotation, or you can see there is spinning. The way we given the name spinning, but how it spins is not what you might think that it has angular spin, like going round in a rotation. Because if you take something like, for example, a lemon like this, right, and you spin it this way, or spin it this way, or spin it this way, or like this, it can spin like this, it can go like this, it can go like this, so it can go infinitely in different ways in its spin. So you can't say it's just rotating a circumference like this, and you draw it this way, you can go this way, it can go this way, and multiple ways it can go. Spinning, you know what spin is in a literal sense. When you define the word spin, if you don't know what is spin, then I think I can't be able to help you. Something, it's not really going round. When you're talking about this, it's not like that. Like when, for example, it's not like, it's just, this is one cycle. So which cycle it is to make this cycle, it's gonna make this cycle, it's gonna make this cycle, it's gonna make this cycle. How many cycles it is gonna make it's gonna spin, which direction is gonna spin. So it's become a jumble of everything here, and this can go on and on infinitely. So you can do it like this until you can no longer see anything. Multiple ways it can move. It's not vibration. If you continue doing this, it will reach a point you can't even see anything. Let's go on and see how much of the spin it is, and how much of this is water spin. See, so it's now become a barbed wire. And if you go on and on and on, let's go spin, and it will spin, and it will spin, and it will spin, and it will spin. You see? But if you put a powerful instrument here, it will be separate all these things, and you will see each differently. So this is what I understand. It's not just one circle spinning like this. Okay, let's not go on with spin and spin. Now I've told you what a spin is. Now it is a particle whose spin is an integer. Integer, it means it's 1 and not a half integer, right? So it's not something, of course we are talking about bosons. We said boson as 1 is an integer spin. Integer means whole number, it's not a half. So this automatically excludes protons, neutrons, quarks and all that, because those are fermions with half integer spin. This one has 1, so it's different. I'm going to know what it is actually. So it has the spin, and it is a particle whose spin is an integer, not a half integer. So a fermion, on the other hand, okay, is a particle, we know that, as already I've told you, it has an half integer spin. So let's see electrons, which is an fermion, so it spins a half. Half. It's a fermion, it's not a boson. It's not a boson, it is a fermion, of course. We have fermion, neutrons, neutrons, what's the protons, quarks. Yeah, there are types of quarks, you know, up quark, strange quark, jump quark, down quark, up quark. Quark is a quark. We've done that already. So what about a photon? A photon in quantum mechanics, what's a photon actually? It's the smallest speck which comes out the quantum of electron, I think, is a photon. Means something smaller than what is the result to give something. It's a phenomenon when you talk of quantum. Okay, so a photon spin 1, and therefore it is a boson. So this light you see, you can categorize it as a boson, because spins 1, and it is also carries electromagnetism. That one much you agree. And you know what's electromagnetism for those who don't know. Electro means electric, and magnetism means magnet. So electric creates magnetism, and the famous rule, thumb, the one, no, the field goes like this. I mean, there's magnetism and there's electricals. They go together. So guys, now let's come upon this. No, this is about quark, so I'm not gonna go there. Sorry, I could have given you before this, but it's not necessary now. How quark, you can take a quark down to preons, up till dew drop to the water molecules. Let's not confuse this video. Here today we're talking about boson and bosons alone. Yeah, man. Bosons. This is what was discovered not long time ago, and the scholar got particle. It is responsible for mass. It gives mass to other things. Without the boson, there will be no mass. I think there's something like it breaks the symmetry in the fields. When you talk of fields, this thing called boson breaks the symmetry which exists in the universe and lends mass to these things like which have mass. Let's say, for example, in an atom, we're having a proton there, we have a neutron there, we have an electron there. We see that we are not including electron, but we're talking of a proton and a neutron to have certain mass in meters. You see, it's like I don't know, I was talking about a quark in the other previous video, I can't remember. They have certain masses associated with them, and what gives them this mass is said to be boson. Somebody singing from outside, guys, don't mind. I think it's good for you to listen to music also. Songs coming from somebody singing, struggling. Okay. By the way, the video I'm making around 5 a.m. so people are still asleep here. Now let's give the examples of what these bosons are. Now, example bosons include what? Include fundamental particles such as photons, gluons, and W and Z bosons. So this boson means we have W boson and we have Z boson. We're gonna go to know what these things are. And in parentheses, given that the 4 forces carrying gauge boson, there's another thing here, new term called gauge bosons of the standard model. Yeah, the names are given these things in order for us to be able to define and understand them. So it has W and Z bosons. Let me come again. Example bosons include fundamental particles such as photons, gluons. We're gonna know about what gluons are. Don't worry. And what W and Z bosons are. They may be different characteristics or properties, but are the same thing in different ways of manifestation, physical manifestation, property, chemical manifestation, whatever. So, the Higgs boson, and the still theoretical graviton of quantum gravity. Why do we say theoretical? Gravity up to now has not been proved what it actually is. Of course, you say matter in nature attract each other, right? And if you go to Newtonians, they say with they attract each other with a proportionality which goes according to their sizes and inversely proportional to the distance between their centers. They attract each other according to Newton. Now, just gravitons is what is radiated by matter, and it travels at the speed of light, and this is what causes gravitational, but it's not known exactly what it is. It has not been quantized. We don't have quantum gravity. It's in theory. It's not practically proved. They say gravity is a very weak force, but it works in a distance. When the distance is long, gravity works. When the distance is small, what works there? Nuclear force, strong nuclear force. I remember from the other videos we've done, when we talk of subatomic, we have nucleus, made out of protons and neutrons, right? And of course the electrons are circulating around there, but their mass is not that much. So it's actually is massless. It's considered not to be, when you talk of atomic number, you're just talking about protons and neutrons, not electrons. Electrons are not included in this because they don't have any mass actually. So quantum gravity is just in theory. It's not known what it is. It can't be measured really, but it's felt. Its effect is everywhere. You are here because of gravity. Gravity attracts you to the ground here on earth where you walk. It's because of gravity, otherwise you'd be floating. The people who go to the station in the outer station, you know, they float. You've seen them in pictures. If you Google now the space station, you see because there's no gravity there. So gravity is real force. And there was something before we said maybe gravity is created by the iron melting down the earth, the core iron, which creates this electricism and magnetism. Is it something like that, and then it forms gravity? So there was something like that. I don't know how true that is. And it keeps attracting or keeping things together, going up from stratosphere, mesosphere, and so on as you go up. Okay, so gravity is here, as they say, that the Higgs boson and the still theoretical gravitons of quantum gravity. So let's go again, because I've talked a lot. What are examples of bosons? They include fundamental particles such as photons, gluons, and W and Z bosons, the Higgs boson, and the still theoretical gravitons of quantum gravity, semicolon, composite particles, e.g. mesons, and stable nuclei of even mass number, such as deuterium. Those are examples. They are giving examples of bosons which include fundamental particles such as the photons, gluons, and W and Z bosons, and the Higgs bosons. Of course, I told you right now that the Higgs boson it has an integral spin of 1, integer spin of 1. So in other words, this also must be falling under the same category. Now Higgs boson and the still theoretical gravitons of quantum gravity, right? Those are examples of bosons. Right? Composite particles, e.g. mesons. Mesons are made out of 2 quarks, 3 quarks. And the stable nuclei. Stable, the word stable is very important here. Stable nuclei of even mass number, not odd number, even mass number, such as deuterium. This is an element, I think, in periodic table, those who do chemistry. Yeah, man. So this is the journey we are going. Now we are finding out this God particle. It was given God particle, but it's not God particle. It was a way of attracting attention to something which is new by giving this name, but it plays a very important role. And you're gonna know exactly. It's a field actually, and when you talk of fields, we're gonna know how this field, according to, is it Faraday, who says that it's continuous, and another, I don't know, I not remember, somebody says quantum. It comes in discrete packets. It's not continuous. Energy is not continuous. It comes in like packets. But another person by the name Faraday says it's continuous. Now these fields have symmetry. We're gonna know about that as we proceed with this. So please stay tuned. These are very, very important lessons we are taking here. It's gonna go down to who are you really? To what is really this energy? No, I was questioning about energy, and when you talk of energy, then I thought about electrons, because electric is electron, so really they have a charge, and the charge means a charge means, for example, when in an atom, if it has extra electrons that it can lose or gain to have stability. And then if all these things are a point of energy, they are point of energy. Whether you're gonna take a blank scale or whatever, and the point of energy is something that cannot be deformed, destroyed. It can only change from one form to another, right? You feel it, you don't see it, of course, with your naked eyes, or even with the instruments that exist. Do you see energy? You can't see, but we talk of potential energy, kinetic energy. In an aircraft, when it's flying, we have the energy being transferred into mechanical, which makes the flaps and slats to move up on the elevators and the radars to move, which means kinetic to mechanical, and mechanical now causes the motion to go. I'm giving an example. I don't mean only aircraft or anything that takes all this kinetic energy from potential to kinetic. Like when you say it's here, this thing has potential energy, and when it goes down like this, then it becomes kinetic energy. Yeah guys, thanks for watching. Stay tuned please to my channel. Like, share and subscribe, and comment. Be part of this journey. It's a great journey we're having, me and you, to understand the nature around us. You know, when you understand things, then you accept them. If you don't understand them, then you don't accept them, then they create a conflict in you. You start to wonder, what is this, what is that? Okay guys, bye for now. See you later in another one. Yeah, in the next one. Bye.